let's take a look at 7.1.38. We're looking for the measure of arc AB. AB is this bit right here. We know this bit. So what we should do is we should use something that we know, like AC is a diameter. We're also given that. And that these two, AB and BC, compose a diameter 180 degrees. So AB plus BC is 180 degrees. AB is equal to 180 degrees, that semicircle, less the measure of BC. Oh yeah, BC was 38. We were given that. So we're going to be able to know that AB is 180 minus 38, 42 degrees. $142 degrees. Alright. Finally, let's take a look at 7.1.40. This is a little bit of a different problem here. We're given that the measure of arc AB is twice the arc of BC. We also know that AC minus 40 degrees is equal to BC. And we want to know what's the measure of angle A. Well, we know that, we know that there's 360 degrees in a circle, and we know that arc AB plus arc BC plus arc, I'm going to say CA, is 360 degrees. We also know their relationship to BC. AB is 2BC. And we know that CA is BC plus 40. So this is 1, 2, 3, 1, 2, 3, 4. BC plus 40 is 360. 4BC gives 320 degrees. Divide by 4. BC is 80 degrees. Now, we know the measure of this arc. But what we need to know is the measure of the angle. We're looking for that angle. Now, this is an inscribed angle because the endpoints intersect the circle, and the intersection of these endpoints right here, A, lies on the circle. So this is an inscribed angle. And the inscribed angle formula tells us that the measure of angle BAC is equal to 1/2 the measure of arc BC. So, if arc BC is 80 degrees, then BAC is half of that. BAC is 40 degrees. You know what? Let's do one more problem. Let's take a look at number 52 in the same section. Excuse the stray marks here. What we're asked to find is, we're asked to show that the measure, or that angle ABC is equal to 1/2 AC. So let's write that down. And that is this angle and this arc. So we're looking to show what we just proved. This is one of the cases that they had. And to do this, we're going to have to get a little creative. I'm going to go ahead and I'm going to draw an arc, or excuse me, draw a diameter. I'm going to start at B here and draw a diameter from B. And so this is going to be BD, and it's going to be a diameter again. We can do that. We can draw diameters from points. That's fine. So, proof. Draw diameter BD. Now, we also know we're allowed to use what we've gotten previously, so we know that the measure of angle ABD is equal to 1/2 the measure of arc AD. That's the first part of this theorem that we're trying to prove. We don't have to prove it now. We don't have to prove it in here. We can use it. And then take a look here. AD is equal to AC plus CD. Okay, and ABD is equal to ABC plus CBD. Okay, but CBD, that's an angle that goes through the origin. We know that, like ABD, it goes through the origin. The problem with ABC, what we were trying to show, is that it doesn't go through the origin. It's an inscribed angle. One of the rays isn't a diameter. We haven't proven that yet. If one side of this angle lies on the diameter, we can use this formula. We can use this formula because BD is a diameter. Because BD is a diameter, we also know that angle CBD is equal to 1/2 of the measure of arc CD. I'm going to draw that here in green. We have this green bit. We know it. We also know what's in, I'm going to draw in blue. We have this measure. We have this measure. That's been proven. We're just looking for this pink stuff. That means a little subtraction. So, ABD equals 1/2 AD. We're going to go back to that. Then we're going to break this down to parts. Instead of ABD, I'm going to write angle ABC plus angle CBD. And instead of writing AD, I'm going to write AC, that arc, plus this arc, CD. Alright. So, corresponding to what's on the circle, CD, CBD. That's the green stuff. Then the magenta that we're looking for is AC and ABC. This. So we've got it in terms of something we know and what we're looking to show. I'm going to distribute that 1/2. So this side is going to become 1/2 arc AC plus 1/2 arc CD. And then my left hand side is going to stay the same. Okay, but wait. 1/2 CD, CBD. These are the same. I can cancel them out. I can subtract that measure, whatever it is, from both sides. And what am I left with here? I'm left with, on my left hand side, angle ABC, and on my right hand side 1/2 AC, which is exactly, I believe, what we were trying to show. There we go, we're done. We had to draw a line, but we were able to show it. We did. Alright. Thank you, and until next time, happy geometering.